Welcome to this video on correlation. By the end of today's video, you should be able to analyze a scatter plot displaying bivariate data, and you should be able to estimate the correlation coefficient of the scatter plot and understand that the correlation does not indicate causation. Alright, so you should have these notes in front of you for correlation and line of best fit. Line of best fit will be tomorrow's notes. So we'll start with the first part of correlation. So correlation is a statistical way to measure a relationship between two sets of data. It's the relationship between two sets of data. Causation is indicating that the relationship between the two events where one event is caused by the other. Okay? So correlation versus causation, you can have a relationship, a correlation, without having causation. So you could have, for this example, there's a correlation or a relationship between the number of firemen fighting a fire and the size of the fire. But the presence of more firemen do not cause the fire to be bigger. So there's not a causation. And you could look at it conversely too. Just because the fire is bigger does not make there be more firemen. What if there aren't any more firemen to bring? So there's not necessarily a causation there, but there's definitely some sort of relationship. So here I have a couple of examples, correlation or causation. So a recent study showed that college students were more likely to vote than their peers who were not in school. Being in college does not make you vote, but it might make you more likely to vote for a variety of different reasons. So there's some sort of relationship. We're going to just call it correlation. Dr. Henderson noticed that there was more trash in the hallway after second period than after first period. Well, just because it's second period does not make there be more trash in the hallway, but there's a relationship there. So we're going to call that correlation. You hit your little sister and she cries. You hit her, it caused her to cry. We're going to call that causation. All right. Now, when we measure correlation, it's a number, okay? And you're always going to use the same variable when you're talking about this number. That variable is going to be R. R stands for correlation. And it will always, always, always be a number between -1 and +1. Okay, so there's four things when you're asked to describe the correlation that you need to take into account. You need to think about its form, which is just its shape. What shape is the data? Okay, the direction. Does it look like it has a positive slope or a negative slope? We'll talk more about that in a minute. How strong is it once you have the number, or you can tell by looking at the graphs that they're stronger, they're scatter plots. And then you would make note if there was any outliers, because outliers can greatly affect your correlation coefficient. Okay? So we're going to start with form, and form just means shape. What shape is the data? So you want to look, this is a scatter plot, so we have X values and we have Y values. If you can see a pattern, always try and envision a line going through the middle of the data. So I'm going to draw it in, and when I look at that, that is pretty straight. So we're going to call that linear. Okay. Now, this next one, I'm going to try and stay in the middle of all the scatter plot dots. And I go up and I'm going to go down. We're about to talk about this shape. This shape you're going to want to memorize. This is quadratic. Okay. Then I'm going to do this next one. We're also going to do this semester. When I look and draw a line kind of through the middle of it, it's kind of a curve that's going to go on forever and ever. Exponential. And then in my last one, I can't see a shape. It's just kind of all over and very scattered, and we're just going to write none. There's no shape, no form. I can't tell you much about it, but really the majority of what we're doing is linear because you cannot have a correlation coefficient without a line, but you'll also need to be expected to know about these other three shapes. Okay? All right, let's go ahead and flip this over. All right, so whenever you're looking at these scatter plots, I want you to always envision a line cutting through the very, very center of them. Okay, we have that, and we have that. Look at the slope of this line. The slope of this line is negative. As x increases, my y decreases. Okay, so that's a negative correlation. So as x increases, y decreases. They go opposite directions, so they're negative. Okay. Then over here, as x increases, y increases. They are going in the same direction. That means it has a positive slope. And you can look at the slope of that line. It's going up instead of going down as you read it from left to right. So now our strength. The strength refers to how close to the imaginary line through the middle of the data set are the points. So let me draw some lines in here. I can't even draw a line in that one. I'm not sure what's going on. All right, so let's take a look. You can see on these outer edge ones, you see how close all of the data points are to the line that I drew through the middle. The tighter the grouping, the more the scatter plot looks like a line, the closer the correlation coefficient is to 1. So in this case, I have a negative slope, so that would be closer to -1. I have a positive slope on this side, so it'd be closer to +1. All right. If we have a bunch of scattering and you can't tell which way to draw a line, I have no idea, that's going to be closer to 0. And then we have a little more scattered out where, you know, I could be guessing here, but I might say this has a negative line, so it's going to be a negative number, maybe -0.5. And we could say that's +0.5. Just to kind of give you an idea. The closer they are to an imaginary line drawn through the center, the closer to 1 they are. That's when we're looking for strength. And let me just kind of make note, because you're going to have to be able to describe this. If the number is a positive or a negative, that's what plus over minus means, 0.7 to 1, we're going to call that strong. If we have positive or negative 0.4 to 0.69, we'll call that moderate. And if we're going to say positive or negative, it doesn't matter which. If it's below 0.39, we'll just call it none. It's going to be pretty scattered. Okay. So, outliers. Outliers fall outside the general pattern. So if we look at this scatter plot, you can very clearly see there's a pattern, but then there's this guy right there. He is outside of the general pattern, so he's probably an outlier. So we'll say outside the general pattern. Okay, so take a look. That one's linear, it's nice and straight. This guy goes up and he comes back down. This guy is quadratic, but you see this one dot that's outside of his pattern. That's going to reduce his correlation, make it weaker. So that would be his outlier. Okay, so now I want to take a second. I want us to put these in order. I gave us 5 correlation coefficients, and we're going to put them in order from the strongest to the weakest. So remember, the positive or negative doesn't matter. The closer to 1 the number is, whether it's +1 or -1, the stronger it is. So when I'm looking at these numbers, the closest to 1 is -0.98. It doesn't matter if it's negative or positive. So that's the strongest one on there. Then I want to look at my next biggest number is 0.87. Now that's a positive, but it doesn't matter because we're talking about how tightly grouped are the dots, okay? The next number is negative 0.81. And then we have 0.43. And then we have 0.07. Strongest, weakest. More like a line, very scattered. Okay? All right, so I have a couple ideas here for you. I gave you 5 choices, and we have 4 examples. So we want to see how close we can get to these. All right, so imagine a line drawn right through the center of the data. So I'm going to draw this line right through the center of the data. See how it's spreading out from that line? That means it's not super close to 1. Okay, so, and this has a positive slope, so I would not say positive 1. Since my only other choice is positive 0.5, I'm going to say this is positive 0.5. Okay. Let's contrast it with this one right here. I have a nice positive slope. When I draw the line, look how close all of those data points are to that line. The closer the data points are to the line, the closer to 1 it is. This is a positive slope, so it can't be either of these negative numbers, and it's not very scattered, so we're going to say that's a positive 1. Okay, let's look at this guy. Draw your line right through the middle. Okay, all the data points are pretty close. It's not as scattered as that. It's got a negative slope, so I'm going to call that negative 1. And then in my last one here, I can't even tell how to draw the line. It's as if somebody took a pen and just made a bunch of random dots. You can't tell if it's positive, you can't tell if it's negative, so we're going to call that a correlation of 0. All right, and we have just a couple more examples. So we're going to decide, is this positive, negative, or no correlation? So what I want you to think of here at these scenarios, think, are the x's and y's going in the same direction? As x increases, y increasing, or is y decreasing? If they go in opposite directions, it's a negative correlation. If they go in the same direction, it's positive correlation. So looking here, the number of hours you work versus the amount of money in your bank account. So the more you work, the more you get paid. As your work goes up, your pay, the amount of money you've been paid, goes up. So this is going to be a positive correlation. Now let's look at the number of hours workers receive safety training versus the number of accidents on the job. It should be the more safety training you have, the less accidents there are. So as x increases, y is decreasing. They're going in opposite direction. So this should be a negative correlation. Look at the third one here, the number of students at Etowah versus the number of dogs in Atlanta. I don't know. I don't think they have any relationship at all. This is a 0 correlation. All right, let's keep going. We're almost there. The number of heaters sold versus the months in order from February to July. So what's happening as we go February, March, April, May, June, and July is the weather's getting warmer. What happens to the number of heaters sold as the weather gets warmer? The number of heaters sold is going to decrease. So these are going to have a negative correlation. And the number of rice dishes eaten and the number of cars on I-75 throughout the day. As far as I can tell, one has really nothing to do with the other. So we're going to call that a no correlation. And our last one, the number of calories burned versus the amount of exercise. The more you exercise, the more calories you burn. They're both increasing. They're both going the same direction. So that's going to be positive. All right, that is all I have for you today. Hopefully that made some sense. Looking forward to seeing you in class.
Yeah.